Good morning, students. All we'll start the ray optics is completed. We are coming to in this week. We'll try to finish the all lessons. We'll start the new lesson, wave optics. See, wave optics are physical optics. Initially, in this, what is the condition for applicability of the geometrical optics? B square by L lambda, if it is 2 greater than 1, we will apply ray optics formulas. Here, what is B means? Size of the obstacle. What is L means? Distance between obstacle and the screen. Distance between obstacle and screen will be L. Lambda is wavelength of the light used. If B square by L lambda is 2 greater than 1, we will apply the ray optics formulas in that case. If B square by L lambda is approximately equal to 1 or 2 less than 1, then we will apply wave optics formulas, means their interference, diffraction and polarization will comes. Next, second one, what is the relation between incident beam and width of the refracted beam? What is the formula here? Is if I is the angle of incidence, R will be angle of refraction. Width of incident beam by width of refracted beam will be cos I by cos R. Remember this formula using Huygens wave principle. How to verify loss of reflection and loss of refraction is there. In loss of refraction, it will come width of the incident beam by width of the refracted beam is equal to cos I by cos R. Next, interference formulas we will discuss. For example, a wave is there. Its displacement is A1 sine omega t plus pi 1. Another wave is there. Its displacement y2 is equal to A2 sine omega t plus pi 2. Pi 1, pi 2 are the phases of that waves. A1, A2 are their amplitudes. Y1, Y2 are their displacements. These two waves combined and form a resultant wave. Then displacement of the resultant wave y is equal to a sine omega t plus pi. The amplitude of the resultant wave means a is equal to square root of a1 square plus a2 square plus 2a1 a2 cos pi, where phi is equal to pi 1 minus pi 2. And intensity of the resultant wave, if I1, I2 are the intensity of these waves, then for that I is equal to I1 plus I2 plus 2 root I1, I2 cos pi. I1 is the intensity of the first wave. I2 is the intensity of the second wave. These two waves combined form a single wave, and its intensity value will be equal to I1 plus I2 plus 2 root I1 I2 cos pi. Next, I maximum by I minimum, how much they will ask. I maximum by I minimum is equal to A maximum by A minimum whole square. A maximum means root I1 plus I2 whole square. A minimum means root I1 minus root I2 whole square. A1 plus A2 whole square by A1 minus A2 whole square. This is important formula, mostly we'll use in a number of problems. So a ratio of I maximum by I minimum they will ask. this value will be equal to A max by A minimum whole square, or root I1 plus I2 whole square by root I1 minus I2 whole square, A1 plus A2 whole square by A1 minus A2 whole square. Next, what is the relation between path difference and phase difference? Path difference is equal to 2 pi by lambda into phase difference is equal to 2 pi by lambda into path difference. And Young's double slit experiment, what is the path difference? This wave coming like this, another wave from S2 coming like this, interfered here. What is meant by interference? Light waves coming from the coherent waves sources superimposed with each other and forming alternative bright and dark bands on the screen is called interference. Light waves coming from the coherent sources are superimposed with each other, forming alternative bright and dark bands on the screen. That will be called as the interference. Young's first in the laboratory, he formed the interference pattern. Okay, here from this slit, one wave is coming like this. From this slit, another wave is coming like this. What is the phase difference between the two waves? Formula for the phase difference will be delta x is equal to d sine theta, or from this sine theta is equal to y by d, so d into y by d. So path reference formula in Young's double slit experiment is d sine theta, or d into y by d. Small d is the distance between the two slits. Capital D is the distance between the slits and the screen. Y is the distance of the point P from the O. Okay. Next, here two waves are mixing. First wave amplitude A sine omega t displacement. Another wave displacement A2 sine omega t plus pi. When these two waves are mixed with each other, resultant wave amplitude will be 2a cos pi by t. In the same manner, resultant wave intensity will be I is equal to 4I naught cos square pi by 2. This is important formula. Next, when bright fringes will be formed, when dark fringes will be formed, what is the condition for path reference, what is the condition for phase reference, like that questions will be there. When path difference is equal to d sine theta, we are indicating if that is equal to n lambda, then at that point P, here at this point P, bright band will be formed. Distance of the nth bright band, this is also important formula. Distance of the nth bright band from central bright band, yn is equal to n lambda d by small d. Okay, lambda will be wavelength of light, capital D is the distance between screen and the slits, small d is the distance between the slits. Next, here what is yn? Position of nth maximum from central bright band. What is the phase difference here means 2 pi n. So n lambda is the path difference. Here we got n lambda is the path difference, or 2 pi n is the phase difference for getting the bright band at the point P. To get the dark band at the point P, what is the path difference means? Delta x is equal to 2n minus 1 into lambda by 2. So for this path difference, then or for this phase difference 2n minus 1 into pi, dark band will be formed at the point P. Next, distance of the nth dark band from the central bright band or from the center, that formula will be 2n minus 1 by 2 into lambda d by d. Now, in this chapter, mainly we will discuss about the interference, diffraction, and polarization. Actually, polarization was deleted in the CET, but it is there in the NEET. Only few formulas will be there on the polarization. We'll discuss this. Next, fringe width. In Young's double slit experiment, what is the fringe width formula means? This value will be equal to beta is equal to lambda capital D by small d. This formula we will use here. Fringe width formula will be beta is equal to lambda capital D by small d. Next, so for which color bandwidth will be more? For red, wavelength will be more. So bandwidth will be more for red color comparing to the violet color, because wavelength of red color is greater than the violet color. Next, this Young's double slit experiment is completely immersed in the water. What will happen to the fringe width? Beta dash will be equal to beta by mu. This formula we will use in that case. So fringe width, what will happen? Mu value will be always greater than 1. So beta dash will be less than beta. So when Young's double slit experiment is completely immersed in water or in a medium, in a liquid of refractive index mu, what will happen to the fringe width means decreases. Mu fringe width will be equal to beta by mu. And see this, in a certain field of U, when wavelength of light lambda 1 is used, N1 fringes are framed. When wavelength of light lambda 2 is used, N2 fringes are formed. Then they will ask to find any N2, like that questions will be there. N1 lambda 1 is equal to N2 lambda 2, or N1 beta 1 is equal to N2 beta 2. This formula we will use there. I used a wavelength of the light is 8,000 angstrom unit. Then 8 fringes are formed. When light of wavelength 6,000 angstrom unit is used, how many fringes will be formed? Like that, questions will be there. There you have to use N1 beta 1 is equal to N2 beta 2. Next, angular fringe width you calculate. Like that, they will ask angular fringe width will be equal to beta by d. This formula we will use for calculating the angular fringe width. Beta is equal to delta lambda is equal to delta theta is equal to delta y by d. That is equal to beta by d or lambda by d. These formulas we will use. Next, here the fringe visibility formula is what? Fringe visibility formula means I max minus I minimum by I max plus I minimum, or this is another formula for fringe visibility, 2 root I1 I2 by I1 plus I2. Missing wavelengths rarely asks need for that. This lateral shift is important. What is meant by lateral shift means? In Young's double slit experiment, what will happen? Here, 2 slits are there. Here, screen is there. This is the point O. These two waves coming from S1 and S2 are interfering at a point P. In this path, I kept one glass plate. From light coming from the upper slit, I kept one glass plate. Then there will be a shift in the bright band position. What is the shift, they will ask. Lateral shift formula will be capital D by small d, mu minus 1 into T, where T is the thickness of this glass slab. Beta will be fringe width, lambda will be wavelength, capital D is distance between the slits and the screen, small d will be distance between the two slits. Here, if you keep this here, it will shift upward. Okay. Here, if you keep this here, it will shift downward. Remember, number of fringes shifted, how many means? Then this formula also we will use here. N is equal to y by beta, mu minus 1 into T by lambda. Okay. So next, diffraction. What is meant by diffraction? Bending of the light at the edges of an obstacle and encroachment of light into the geometrical shadow is called diffraction. Diffraction due to a single slit in that condition for minimum intensity means this is the formula. Condition for maximum intensity means A sin theta is equal to 2n plus 1 into lambda by 2. Quite opposite to the interference, it will be there. Condition for the minimum intensity, what is the formula there? What is the path reference? 2n minus 1 into lambda by 2. Here 2n plus 1 into lambda by 2, that is for maximum intensity. For minimum intensity, what is the condition means? Minimum intensity, that 2n minus 1 into lambda by 2. Maximum intensity condition is what for interference? N lambda. Here that condition is there for minimum intensity. For maximum intensity, there N lambda. Here 2n plus 1 into lambda by 2. Okay. Next, to find this y value, like that questions will be there. Y is equal to lambda capital D by small a. What is a here? Width of this. Next, width of the central maxima, they will ask here. W is equal to 2f lambda by a. Okay. Next, resolving power of the microscope and telescope. Previously, questions will be asked on this concept. Resolving limit of a microscope. What is the resolving limit of a microscope means? That formula will be 1.22 to lambda by 2 mu sin alpha. Resolving power formula will be 2 mu sin alpha by 1.22 lambda. This is the formula for resolving power of the microscope. This is the formula for resolving limit of the microscope. Next, resolving power of the telescope. Formula will be 1.22 lambda by a, where a is the diameter of the lens. Okay. Next, here resolving power of the resolving limit. This is resolving power will be a by 1.22 lambda. A is the diameter of the objective of the telescope. Lambda is the wavelength of light. Now next, what is meant by polarization? Polarization means light intensity will decreases when it passes through some crystals. And actually, light is an electromagnetic wave. So electric field vectors, magnetic field vectors will be there. Magnetic field vectors we can't trace. In the electric field also, perpendicular components of light will be there, parallel components will be there. When light passes through some crystals, then that crystal will stop one component and it will yellow another component. That is called polarization. In the naked eye, we can't say whether that light is polarized light or unpolarized light. We can't say with the naked eye. But generally what we will say is comparing to the normal light, polarized light intensity will be less. Okay. When we send the light through some crystals, ordinary light through some crystals, light will acquire one-sidedness, or that crystal will stop one component of light and allow another component of light. That phenomenon is called as the polarization. So Brewster's law will come in polarization when light is incident. For example, here one glass plate is there. This is ordinary light. It will have parallel components and perpendicular components. These arrows are parallel components, dots are perpendicular components. Incident on it, only 3 to 5% of the light will be reflected, and it has only perpendicular components. Refracted light will have mixed one. Some will have both parallel and perpendicular components. Somewhere only parallel components will be there. So here this angle will be called, here if you draw a normal, this angle will be called Brewster angle or polarizing angle. Relation between refractive index of this glass plate and polarizing angle is mu is equal to tan theta p. Okay. This will be reflected light. This will be refracted light. Both will be perpendicular to each other. These two are perpendicular to each other. Okay. Problems will be there on Brewster's law. Mu is equal to tan theta p. And in NEET it will be there. Entire polarization concept was removed in the CET. If you opting for CET, just neglect this polarization. Okay, like this. This is unpolarized light. This is polarized light. And this is partially polarized light. For glass, what is the polarizing angle or Brewster's angle? Means 57.5 degrees. For water, what is the polarizing angle? Means 53 degrees. Malus law, what it is saying is I is equal to I naught by 2 cos square theta. When a light of intensity I naught, amplitude A naught, incident on a polarizer, its intensity becomes I naught by 2, its amplitude becomes A naught by 2. Again, this light when passes through an analyzer, its intensity becomes I naught by 2 cos square theta. Theta is the angle between the two axes, and amplitude will be A naught by root 2. Next, P1, P2, P3 are the polarizers. Then angle between P1 and P2 is theta 1. Theta 2 is the angle between P2 and P3. Then I value will be I naught by 2 cos square theta 1 cos square theta 2. This formula we will use here. So this is enough. These formulas are enough. What I made a bracket important, those are important, like that you prepare, all you prepare, and we'll start doing the problems on this. Okay, we'll stop this session now.